Hello, this is Yinchi Huang. I'm doing the homework 10 problem 2. The first is the WSS process, the wide stationary process. And the stochastic process is called the WSS process if its mean is a constant and the autocorrelation is a function of time difference. We are already very familiar with WSS process because we have done a lot of practice in the previous homework. And the second one is the independent increment process. The definition is that if xt minus xt1 minus xt2 and xt3 minus xt4 on non-overlapping intervals and they are independent. And we know there are some of the process we already know, which is the independent increment process. And it includes the Poisson process and the random walk and the Wiener process. And the third one is the Markov process. And the definition is that if a process xt is a Markov process, if the past has no influence on the future when the present is known. And so far we see that the Poisson process, the Poisson impulse, and the semi-random telegraph, the random walk, and the Wiener process, they are all Markov process. And it's very useful. And the fourth one is the normal process. The normal process is also called the Gauss process. And it has the definition that process xt is said to be normal if the random variables xt1, xt2, until xtn are jointly normal for any t1, t2 until tn. And we have a lot of normal process. We have already seen a lot of normal process already, and we are familiar with this. And the next one is the strict stationary process. And this process is said to be SSS process if its statistic is not affected by a shift on the time axis. And this condition is very hard to meet. And the next one is the white noise. A stochastic process xt is said to be white noise if the mean of it is 0 and the autocorrelation is this one. And we only have the definition there, and we are not very familiar with the white noises. And the next one is the ME process. And it has a definition there, and we have done another homework problem in the homework 10, and so we have more ways to tell whether a process is a ME process. Firstly, the mean or the expectation must be a constant, and we have two ways to tell whether a process is a WE process. The first is the limitation of this one equals to 0, and the second one is in the definition. And we also have the sufficient condition to tell whether it is a ME process. If xt is WSS, and we can use this formula to tell whether it is a ME process. And also if xt is WSS, and we can see the limitation of c tau, and when tau is approaching infinite equals to 0, and xt is ME process, and that's all.